And so, probability of an event is the number of ways that an event E can occur. So, if we're looking at blue, for example, there's only one way that that event can occur. Drawing a blue marble, there's only one way, over the total number of outcomes, which is all 12 marbles could be pulled out of the bag, which are different outcomes. Uh, this composition of marbles in the bag is called the sample space because that is all of the different outcomes that we can see when we draw one marble. So probability of green, 6 out of 12 because there are 6 greens out of total of 12. Probability of blue, 1 out of 12 since there's one blue out of 12 marbles. Next, we're going to talk about odds. So, odds of an event. It's very similar to probability, except when we talk about odds, um, it's more of just like a ratio of a number to another number rather than a fraction. It's also a little bit different in that we look at um, an event happening versus it not happening, rather than an event happening versus the total number of events. We're going to say number of ways E can occur, 2, and we're going to use a colon there to signify the 2. So this will be one number, right? Number of ways that E can occur. 2, the number of ways E does not occur or doesn't occur. Right, so a number to another number, and it's essentially how many ways can this event happen, and how many ways can this event not happen. So, from the example above, or continuing from the example above, the odds of green, if one marble is drawn, is going to be a ratio of a number to another number. The first number is the number of ways we can draw a 6. How many different ways can we draw? Sorry, not 6. How many different ways can we draw a green marble? Essentially, the number of green marbles is 6. There's 6 different ways to get a green. 2, how many different ways can we not get a green? 6 as well. Good. So the odds of getting a green are, we would say, 6 to 6. So this, we would read this as 6 to 6. Okay, you should understand how that's read. Let's do odds of red, since we haven't really done any problems with red yet. What would the odds of getting a red be then, if we applied the same logic here? Yeah, good. So 5 to 7, because there are 5 ways to get a red and 7 ways to not get a red, right? And this is 5 to 7, right? That's how we read those. Something about this that should make sense is that these two numbers will always add up to the size of our sample space, right? Because it's an event happening to an event not happening. So if we add those up, that should add up to everything that can happen, right? This 5 ways of getting a red and this 7 ways of not getting a red should cover the whole sample space of all 12 marbles. Are there any questions on probability or odds?
I
Okay.
have a question.
Yeah, go for it.
For odds, if how would it work if we drew more than just one marble? Like if it were like two or three?
Um, like if you drew two marbles and said the odds of one green, one red, something like that, we would have to.
Uh,
Go ahead.
I was gonna say yeah. If it was just like oh yeah, like would the question just be like yeah, drawing two marbles like one green, one red, or would it be like oh if it's drawing two green marbles?
Okay. Um, you could, as soon as you go to two marbles or more, it complicates the how you count the number of ways E can occur. Um, and we are going to do more. I think we're going to do more counting problem stuff. Actually, no, I think we're done doing counting problems. So we kind of employ the use of those counting problem strategies where we did like the permutations, combinations in the last chapter in order to count the number of ways that we can draw two green marbles, for example. So um, if we're drawing two marbles and we say what are the odds of getting two green marbles that we when we draw two marbles, we would have to count the number of ways that that can happen. So the number of ways we can get two greens is we would have to take all six of these greens and we would have to do something like a six choose two, or sorry, we did 6C2 to count the number of different ways we can get two marbles that are green, right? And that would count the number of ways to get a green marble. And then we would say two, the opposite of that, which would be counting everything else that could happen when you draw two marbles. So it does get a lot more complicated, and I don't think anything in the worksheet is going to get that complicated for now. And if it does, we'll go into more detail then. But that's a great question. It just gets this idea stays the same. When you're doing odds, you have to somehow count the number of ways that you can satisfy this event, and then the rest of it is your other side. Cool. Um, I just looked at the worksheet. The worksheet talks about a deck of playing cards, and that's you are going to need to know the composition of a deck of playing cards. So if you go to the next page in the workbook, you have a nice picture of a full deck of playing cards, and whoever took this picture didn't do a very good job of it because two of the cards are like on top of each other right here. So you're kind of not seeing the 10 of clubs there. But we can take some notes on this page real quick on the composition of a deck of cards. They're in four groups for a reason. These are called the suits of a deck. And if you look on the right side of the page here, I don't know if I can turn this page. Can I turn a page on here? Rotate page. Clockwise 90. Ooh, look at that. Okay, so if we're looking at this deck of cards, you turn your book sideways. There's some information given here. There's also a typo here, so let's fix that as well. This should say 13 diamonds instead of 12. Actually, can I actually fix this though? Perfect. That should say 13 diamonds, 13 hearts, 13 clubs, and 13 spades. So what do those mean? Those are the different little symbols on each card. Okay, you see that these are gathered into four different groups. The first group here, those are the spades. So if you want to make note on here, in like a with a colored pen or something, these are spades. These are the clubs. These are the hearts. And these are the diamonds. If you look at the fanned out cards, there are 13 individual cards in each of these suits. This ace sometimes is used as a 1 before the 2, or sometimes it goes on the other end of the deck as a number that's higher than king. So numbers go 2, 3, 4, 5, 6, 7, 8, 9, 10, and then the cards go jack, queen, and king. So if you want to make little notes of like what each of these is, that's a jack. That's referred to as a jack. This is a queen, and this is a king. And this first one here is called an ace. If you already know what a deck of cards looks like, then this is kind of just like pointless for you. But there are people that have never actually like thoroughly examined a deck of cards, so we're doing that right now for those people. What else is important here? There are 13 in each suit, like we said. Notice that there are 2 colors of cards. There's the black cards up here, and since that accounts for these 2 suits, that's going to be 26 black cards and 26 red cards, right? That's another distinction that we have here down in the bottom or in the side notes. There's 52 cards total. There's 13, 13, 13, 13, which adds up to 52. And then the last thing I want to say is these guys, the jack, queen, king, are called face cards, because they have pictures of people's faces on them, right? So if we look at we can't really see the queens and the jacks, but these 3 cards are specifically called face cards because they have faces on them. So if we consider the whole deck, how many face cards would there be?
12.
Perfect. There's 3 here, 3 here, 3 here, and 3 here, right? So there's going to be probability questions. A deck of cards is a very good tool for doing probability questions because you have a bunch of different characteristics of cards. So if you have like a full deck of 52 cards and you draw a single card out of a deck, you can ask questions like, what is the probability that it's a face card? What is the probability that it's black? What is the probability that it's a diamond? And so on. And then we can kind of compound that into asking questions like, what is the probability that it's an 8 or it's a black card, right? So we can compound this with or statements, or we can compound it with and statements, like what is the probability that the card is a king and it's red, right? So we're going to do these types of problems, not necessarily today because we're just starting the probability section, but going forward, as you do deck of cards problems, you can refer to this page number 35 in your workbook, or you can look up a picture of a deck of cards. But as you do more and more problems, try to commit this like structure of a deck to your memory, because you're not going to have this picture when it comes to the exam. You don't really want to waste room on your flashcard for writing out the deck of cards, right? So try to commit some of this stuff to your memory as you're working through the problems.